Hello students, hope all of you are well. So today I welcome all of you to this session where we are want to discuss the multiple integrals for the variable limits. For the previous video lecture already I have provided some of the examples along with the definition and the concepts of the double and triple integration with the constant limits. So if you have not checked that video, please check it, thereafter come to this video because this is the advanced version of the previous video lecture. So let us start our today's discussion. So as we have discussed in the last lecture that the double integral can be done with the two cases. First case is the constant limit case and second one is the variable limit case. So let us try to understand how the limits are be variable whenever we are doing the double integration. So under the variable limit case we are having two cases. First case is that the limit of x is constant where the limit of y is variable. Now how it can happen? So let us try to understand the situation. So we are having a non-rectangular shape of region R over which we have to do the integration of the function f of xy. It have to be mentioned properly that if we are having the rectangular shape of region, then the limits of the both variables must be constant. But since we are having non-rectangular shape of region, it can be any kind of shape. It can be circular shape, it can be parabolic, it can be ellipse, it can be intersection of any two different types of curves, but it should not be in the shape of a rectangle. Then only the case of the variable limits occur. So here we are discussing the first case where for the non-rectangular shape of region we have to fix the limit of x as constant where y will be the variable limit. So suppose the limit of x is a constant, say a less equals to x less equals to b, a and b are the constant values and y will be depending on the function of x. So limit of y is going to be a variable limit phi1 x to phi2 x. Now how to perform the integration? Double integration over r, that is f of xy dy dx, we have to do in this manner, that is integration x equal to a to b should be written outside because it is the constant limit. Since the y limit is variable, so we have to do the integration of the function f of xy first with respect to variable y, since the limit of y is variable. So integration with respect to y will be inside phi1 x to phi2 x f of xy dy dx. So this is the structure whenever x is constant and y is variable. Now let us come to the case number 2 where we will see that y is going to be constant and x can be a variable limit. So the similar type of thing is happen here. X is variable and y is constant. Suppose for the region R which is placed in the xy plane, for that region the y limit is constant c to d and the limit of x is now depends on the function y, phi1 y to phi2 y. So since x limit is a variable limit, so we have to do the integration of f of xy first with respect to the variable x, thereafter we have to do with respect to y. So y integration will be outside c to d and inside we have to first perform the integration with respect to x. So x limit is phi1 y to phi2 f of xy dx, thereafter the outer portion we have to perform. Now let us try to understand all these concepts using different types of problems. So first the question is that we have to evaluate double integration over the region R of xy dx into dy, where R is given as the region in xy plane and which is bounded by y equals to x and x equals to 1. Now you remember whenever the integration will be given like this, then dx dy, this order should not be same always. That is, here as per the conventional rule that we have learned in the previous video lecture, that since dx is coming first, so we have to perform the integration with respect to x. Y is coming second, so we have to perform y outer. This is not necessary if the region is prescribed in this manner, but if the limit of the integration is given along with the integration, then we have to follow the previous steps. But here, since the region is given, so it is not mandatory that this order should be given in the perfect way. To make you little bit confused, this type of order can be given. Now we will try to find out the region R, which is the most important part of this kind of problem. So every time you have to draw the region, based on that you have to perform the integration. So on the right hand side you can see that I have drawn the diagram of the region. So here we are having x-axis and y-axis, and y equals to x, that is the straight line, and x equal to 1, the line which is parallel to y-axis. So there they will intersect each other at a point capital A, which is having the coordinate 1, 1. So this is the portion over which we have to do the integration. So this is the shaded region. If I do the shading, then it will be easily understandable for all of you that over this region basically we have to perform the integration. So definitely from this region you can be able to understand it is not in the shape of a rectangular domain. So since it is not a shape of a rectangular region, the limits of x and y cannot be both constant. So suppose for our choice of the integration, we want to make the x will be constant and y should be variable. Now to make x constant, we have to find out from which point to which point x is varying. So the first starting point of this whole region, it starts from the point 0, 0, and the last point where x will stop its progress at the point 1, 0. So this is the whole region over which x will vary. So x will vary from 0 to 1. Now always remember, x we measure along the horizontal direction, where y we will measure along the vertical direction. Now how to measure y for this rectangle? How we can get this rectangle? So to get the rectangle, we have to start y from the x-axis and we have to go straight up to the line y equals to x, right? So y will start from x-axis and y maximum will go up to y equals to x. So at the x-axis the value of y equals to 0, and at the line, this straight line, the value of y is x. So what is the range of x? So x will ranges, the range of y will be 0 to x, because we are measuring y vertically starting from x-axis to the straight line y equals to x. So how to perform the rest of the integration? This is now, it is quite easy to do. So double integration over r x y dx dy. So x integration we have to do outside because it is constant limit, x equal to 0 to 1. Since y is variable limit, so it will go inside, y equal to 0 to x, x into y. So now we have to arrange as per the limits we received. So y we have to do first, thereafter we have to perform the integration with respect to x. So now let us try to finish the integration. So here x equal to 0 to 1 will be outside. Since we are performing the integration with respect to y, so x will be treated as a constant. So integration of y is y square divided by 2. Now limit of y we have to put, that is 0 to x. Since already one x is there which is treated as constant, so we can keep it like this. And rest of the integration we have to perform with respect to x only. So what we will get from here, x equal to 0 to 1, x into y we have to substitute by x. So x square and x is coming, x cube will be there. So x cube divided by 2 dx. Now x cube integration is x to the power 4 divided by 4, already 2 is there, so 4 into 2, that is 8, and the limit of x is 0 to 1, so the value of the integration is coming as 1 upon 8. Now let us come to the next problem. We have to evaluate the double integration over the region R for dy into dx, where R is the region in the xy plane which is bounded by two curves, x square equal to 4y and y square equals to 4x. So x square equal to 4y is a parabola and y square equals to 4x is another parabola. So x square equal to 4y is a parabola which is in the shape of U, and y square equal to 4x is the C shape parabola. So both the parabolas intersect at a point A, that is equal to 4 comma 4. We'll discuss how it is coming. Now in between these two parabola, the intersected portion, which is the common portion between these two parabola, is bounded by this shaded portion. This is the region, so over which we have to do the integration. So here capital R, we can see this is the shaded domain. Okay, now how to get the point of intersection between these two parabolas? So to find the point of intersection A, we have to put the value of y from one parabola to another parabola. So here from this parabola we can see the value of y can be taken as x square by 4. So if we substitute the value of y in the second parabola, then we will get the equation like this. After solving this equation, we get the values of x, and both the values of x are coming, x equals to 0 and x equal to 4. So x equal to 0 is the origin where the coordinate is 0 comma 0, and another point is 4 comma 4, because if we put x equal to 4, y is also coming 4. Now from this point what we have to do, we have to draw a perpendicular to the x-axis. So it will meet the x-axis at a point B, 4 comma 0. So this should be the range of x for which this whole portion will lie. So how we can identify the limit of x now? I have already told you that we have to measure x along the horizontal direction. So for these 2 points 0 to 4 comma 0, the x is lying, right? So 0 less equals to x less equal to 4. So this is the limit of x. So x limit is becoming constant. Now how to identify the limit of y? Already I have told you that y we are measuring in the vertical direction. So since y we are measuring in the vertical direction, we have to shade this region by vertical lines. So if I draw any particular vertical line, so what you can see that y is starting from the lower parabola and it will go up to the upper parabola. So in the lower parabola, what is the value of y? Y equals to x square divided by 4. And in the upper parabola, what is the value of y? Y equals to root over of 4x. So that is equal to 2 root over of x, because if we just shade this region by vertical lines, then you will be able to understand. So y we are starting from the lower parabola and y is ending to the upper parabola, because this is the only region we have to cover. So we have written the limits of y and x here in the integration. So what we get from there, that is x is ranging from 0 to 4, where y is ranging from x square by 4 to 2 root x. First we have to perform with respect to dy, thereafter we have to perform with respect to dx. So now x is going from 0 to 1, nothing is there, so constant 1 is there. Integration of dy is y only. We have to put the upper limit and lower limit. So x equal to 0 to 1, 2 root over of x minus x square by 4 dx. Now to perform this, we have to write down 2 into x to the power half. So x to the power half plus 1, so it will become 3 by 2 divided by 3 by 2 minus x to the power 3 by 3 into 4, that is 12. So limit of x we can put as 0 to 1. So it can be written as 2 into 2 divided by 3, x to the power 3 by 2. If we put x equal to 1, it will become 1 only, minus 1 upon 12. So 4 by 3 minus 1 by 12. If we take the LCM, it is coming 12 only. 3 into 4 for 16 minus 1. So it is coming 15 upon 12. So we can cancel with 3. So it is coming 5 by 4. So this is going to be the result. Okay. Now let us come to the another example. Similar type of example we are having here. So let us evaluate double integration over the region R, x into y dx into dy, which is bounded by x-axis x equals to 2a and x square equal to 4ay. So x square equal to 4ay, that is a parabola which is in the shape of U type, and x equal to 2a is a straight line which is parallel to y-axis. So in between these two curves and bounded by x-axis, we are having one region that you can see that I am shading here. So this is the region over which we have to perform the integration. So this is our region R. Now how to find out the region R for which x will vary and y will vary? So let us try to identify the point. So this straight line will intersect this parabola at a point B, 2a comma a. How to get this value? Very simple. You put x equal to 2a in this x square equal to 4ay. You will get the value of x y itself. So b coordinate is 2a comma a, and this point is going to be 2a comma 0. So x is varying from 0 to 2a. So the limit of x is going to be 0 less equals to x less equal to 2a. Now the same thing, that x we are measuring along the horizontal direction. That's why I have taken this range for x. Now how to get the value of y for this domain? We have to take a perpendicular from this x-axis to the upper curve, because this shaded portion is our required region. So in x-axis the value of y is 0, and in the above this curve, what is the value of y? Y equals to x square divided by 4a. So we can put the limits now. We can come to the limits now. So what is the limit of x? X is varying from 0 to 2a. And what is the limit of y? Y is varying from 0 to x square divided by 4a. X into y dy dx. Now let us integrate. Since we are doing the integration with respect to y only, so we have to consider x as constant. So I have taken x here. Outside, the integration of y is y square by 2. We are putting the upper limit and the lower limit. After simplifying, we are having x to the power 5 divided by 32a square. Now we will integrate x to the power 5. We will get x to the power 6 upon 6. 1 by 32a square is already taken outside. 0 to 2a. Once we will put the limit and simplify, we will get the answer as a to the power 4 by 3. Now let us come to the next problem. It is little bit difficult and hard problem, so we will try to find out the solution also. Double integration over the region R for the function x square plus y square dx dy, where R is bounded by the curves x equals to y square, x plus y equals to 2, y equals to 0, and y equals to 1. So many things have been given to draw the region. First of all, y square equals to x. This is a C-type parabola. X plus y equal to 2. This is the blue straight line that you can see. That is the line x plus y equals to 2. Y equals to 0 is our x-axis, and y equals to 1, this will pass through the point of intersection of this parabola and the straight line x plus y equals to 2. How we can get this point of intersection? It is very simple. You just substitute x equal to y square in this expression, you will get the value of y. Okay, so from there we will get, so here all these lines basically bound only one region. This is the region which I am shading here. Okay, so this region over which we have to perform the integration, this is the region R. Now if you look at this region, basically this region, the top of this region are defined by two different curves. If I make a perpendicular from B to the x-axis, the point of contact is capital A having the coordinate 1, 0. So on the left hand side of A, the upper value of the curve will come from y equals to x square, while on the right hand side of A point, the upper curve will give from the value x plus y equals to 2. So since we are having two different regions bounded, the top curve is different, so the whole region R we have to split into two parts. Now let us come to the answer. So we have first of all splitted the region into two parts, R1 and R2. Now let us come to find out the limits of the points. Now if you look at the structure for 0 to 1, for 0 to A, what is the range of x? All of you can understood now, I think. So x is ranging from 0 to 1. So since x is constant, we are taking the limit of x as 0 to 1, and this integration we have to do later. Now how to measure y? Same thing, that we have to draw some perpendicular from x-axis to the upper curve. So at x-axis the value of y is 0. On the upper curve, this is the curve. So in this curve, what is the value of y? Y equals to root over of x. So y will vary from 0 to root over of x. This will be inside. So first we have to perform the integration with respect to dy, then with respect to dx. Now we come to the next part, right hand side of A. So for right hand side of A, now x will start moving from 1 and it will go maximum up to C, A to C. So between A to C, x ranges from 1 to 2. So we have taken the range of x as 1 to 2. While the top, how to get the value? Again we have to draw perpendicular from x-axis to the upper curve. So x-axis value of y is 0. On the upper curve, what is the value of y? Y is equals to 2 minus x. So y will ranges from 0 to 2 minus x. Okay, now so the same thing now we have to do. I no need to explain, I think, because already many problems I have explained so far. So you can check out the integration right now. Just we have done the integration in the similar way, and we have substituted the limits, upper limit minus lower limit, and thereafter sorry, something is got deleted because of this structure. So x to the power, I think here 5 by 2 is coming, 7 by 2 divided by 7 by 2. So it is going to be plus and x to the power 5 by 2 it will be, okay, and 3 into 5 by 2, and okay. So the rest of the part is okay. So final answer is coming as 149 divided by 105. So these are about the double integration. Now let us have a look for the triple integration and its structure. So in our exam we can have any one of these two type of questions, so we need to understand it very carefully. So what is the triple integration? The structure will be quite similar to the double integration, but here we are having one domain which is in the shape of a suppose a surface or can be a volume. Okay, so here we have to perform the volume integration for f of xyz over dz, perform dx dy dz. Actually it should not be dz only, it will be dx dy and dz. Okay, now definitely the region should not be shaped of the rectangular three-dimensional diagram, right? So it should not be in the shape of a rectangular shape of the diagram, that is parallelepiped. So if it is a non-parallelepiped type of structure, then only we will be able to apply this concept of the variable limit. Now for the triple integration, the variable limit will be in the following manner. Usually we see this structure happens, that is z is a function of x and y, so z will depends on both the variables x as well as y. Because we have to take the projection from z plane, we will come to the xy plane. So whenever we will come to the xy plane, then either x will depend on y or y can be depend on x. So here we have written y depends on x. And lastly, if y depends on x, so x limit is going to be constant. So this is the structure. So z will depend on two variable, so I can split it in this manner. So for three-dimensional integration, so we have z which will depend on two variables x and y. Thereafter, whenever we come to y, then y will depends on x, and ultimately x is constant. So these are the steps we have to fit inside our head so that we will be able to do this problem. Now the structure can be little bit altered also. Sometime y is a function of x, it can be x is a function of y also, then y will be constant. Okay, so let us try to understand with some problem. So here the first integration that I have given here, it is important for your exam, that is the integration 0 to 1 0 to 1, 0 to root over of 1 minus x square, 0 to root over of 1 minus x square minus y square dz dy dx divided by root over of 1 minus x square minus y square minus z square. So now definitely what you can understand from here, the first limit, if you look at this, limit is depending on two variable x as well as y, so it must be a limit of z. So the innermost integration we have to perform first with respect to z. Thereafter, if we come to the second one, we can see it depends on x, so y, it should be a function of y only, so y is going from 0 to root over of 1 minus x square, and lastly x is remaining, so it will be limit of x. So this is the way we have to identify the limits. Now the structure is given as dz, since we have to perform with respect to z, so I have taken dz first, dy dx later, root over of 1 minus x square minus y square minus z square. Don't be afraid of such a big integration, it is quite easy to do, because since whenever we are doing the integration with respect to z, x, y, 1 all will be treated as constant. So it is following the structure integration of dx upon root over of a square minus x square. So what is the integration formula for this? This is sine inverse of x upon a plus c. So what is a square here? A square is your 1 minus x square minus y square. So what is your a? Root over of 1 minus x square minus y square. So simply the first integration will give us sine inverse of z upon a, that is z upon root over of 1 minus x square minus y square. Limit of z we have to substitute. So the same thing, if we substitute here z limit, so it is coming sine inverse of 1 minus sine inverse of 0. So this value is going to be sine inverse of 1 is pi by 2 and sine inverse of 0 is 0. So inside the integration you can see the result is coming as pi by 2. Okay, now pi by 2 is constant, you can take it outside. Integration of dy is y, limit is we have substituted root over of 1 minus x square. So it is coming root over of 1 minus x square dx. Now to perform this integration you have to remember another formula, that is root over of a square minus x square dx. What is the formula for this? X divided by 2 root over of a square minus x square plus a square divided by 2 sine inverse of x by a, plus some constant c, since it is indefinite integral. But since here we are having definite integral, no need to put c. Okay, so in place of a we are having 1 here, so we have applied the formula x by 2 root over of 1 minus x square plus 1 by 2 sine inverse of x, 0 to 1, pi by 2 is already there, so we have written pi by 2 here. So ultimately the result is coming pi square by 8 after putting the limit 1, because if we put 1, the first term is going to vanish. From the second term we are having sine inverse of 1 is pi by 2, so pi by 2 is already outside. 1 by 2 into pi by 2, result is coming pi square divided by 8. Now let us come to our today's last problem, that is the problem number 6. Identify the limits of the variables, then integrate. So sometime to make you confused, the integration should be given in this manner, that is randomly dx dy dz can be plotted, so you should not get afraid by getting this type of things. But it should not be that x is having the limit 0 to 1 minus x is having the limit 0 to 1 minus x, y is having the limit y square to 1. It should not be like this, because one function cannot be the limit of itself. Okay, so how to understand? So the general structure that I have told you, if in any limit you can see x, y both are coming, then it should be a function of z only. So we are considering the innermost limit depends on function of x, so we can think that here y is also present, but the coefficient of y is 0. So we can imagine that 1 minus x is a limit of z with coefficient of y is 0. So the innermost integration have to done with respect to z only. Now we come to the second integration. For second integration we can see the limit is starting from y square to 1. So since it is y square to 1, it cannot be limit of y, so it must be limit of x. So we are having that y square to 1 as the limit of x, the same thing that I have written here, that you can be able to see. Now ultimately we are having the outside limit 0 to 1, so it must be limit of y. So first limit is the limit of z, that is 0 less equals to z less equals to 1 minus x plus 0 into y, coefficient of y is considered as 0. Secondly the limit of y x, and thirdly the limit of y. Okay, now let us come to the solution part. So we have to do the okay, so we can see the solution that we have done here. It is quite simple to understand. Already we have done many questions. Now you can be able to understand it easily. So x equal y square to 1, it should be the integration. So first of all we have done the integration with respect to z, substituted the limit of z 1 minus x, so x into 1 minus x, x minus x square. Now we have to perform with respect to x, and thereafter we have to do the integration with respect to y, and finally we have to substitute the limit of y, and we will get the final answer as 4 by 35. So this is the way that you can perform the integrations. We are having more questions of variable limits in the change of order of integration, Cartesian to polar coordinate, finding area and finding volume. So if you have understood this video, then please check out the next videos also. Thank you all.